does is it realizes multiplication. Okay. The idea of how and why doing the sequence of so basically we're going to do a sequence of shifts, additions or subtractions depending on a few parameters. We'll do it over and over again, repeat it a number of times. You will see how it is done. So what you should try and grasp now is the mechanical aspect of it. Just don't worry about how the logics of it work as yet. Professor will go through it thoroughly in class. Try and grasp first how this is mechanically is done. Right? Just given this problem, how will I accomplish multiplication by doing a sequence of shifts and additions or subtractions? Okay. So.
Are those numbers you've written supposed to be different?
This and this.
Yeah.
So, pardon?
No, same.
Right. You have the multiplicand here, and then you have the multiplier here.
Okay. That's what I meant.
Yeah. This is your multiplier, and this is your multiplier. Okay. So, essentially, what we do is, at every stage, we check for these last two bits. Okay. So these last two bits will either be will be one of the four combinations. They'll either be a 0, 0, 0, 1, 1, 0, or 1, 1. Okay. Depending on what the value is, we do one of the following. We either do nothing in the case of 0, 0, or 1, 1. If it is 0, 1, what we do is we add the multiplicand here. Okay? If it is 1, 0, we take 2's complement of the multiplicand and we add it. Starting from the MSB. Okay? So, this is how it's going to go. Depending on this, I will determine if I want to add it or subtract it or do nothing with it. Okay? If I find out that I need to add it or subtract it, I will bring this down here, add it with whatever values. So initially all this is 0. Okay? So add it or subtract it with whatever is here. Okay? After that, the next step is going to be, I'm going to shift my value. Shift it right once. So essentially whatever was over here drops out. Since this was 1, 0, 0 would drop out and I would have 0, 1 here. Right? And I keep doing this until all the bits of my multiplier have dropped out.
Good.
Okay? Again, you should understand the logical aspect of this, right? But first let's try and understand how mechanically this is accomplished. Okay? So let's start. Initially I have 0, 0. Okay? First step I see I have a 1, 0. 1, 0 means I need to subtract. Okay? I have, for our convenience, written down 2's complement out here. So essentially the next step I will have 1, 1, 0, 1, 0. Okay? And this stayed as it is. Okay? So that was my first step. Next step is my shift. Okay? So essentially I shift this. Now, one thing you need to remember while shifting is it's sign extended shifting. We all know what sign extended shifting is, right? So if my MSB is 1, when I shift it, my MSB grows to be 1.
Right.
So so essentially what I'm trying to do is if it's a negative number, I maintain the fact that it's a negative number. So I move this, the MSB was 1, let this stay 1, I have 1, 1, 0, 1, 0, 1, 0, 1. This dropped out. I have a 0, 1. I again repeat what I did before. I have a 0, 1. What is 0, 1 supposed to do? 0, 1 means I need to add. So I bring this multiplicand, 0, 0, 1, 1, 0. I add it with this. Again, it's aligned with the MSB. So how I add right now is 0, 0, 1, 1, 0. Okay?
So you're just adding with the...
I'm just adding. And I'm not even aligning it. So what I want to make sure that you guys notice is I'm not shifting it that way. I'm adding it aligned with MSB. Right? I'm starting addition from here. So I have 0, 0, 1, 1, 0, adding it to this. So the value I get over here is, so everything else remains the same. I'm going to copy it out. Over here I have 1, 1, 0, carry, carry, carry dropped out. Did you get the addition? Let me make sure that the addition is right. 0, 0, 1, 1. Perfect. Okay. Next step. Oh, next step is shift again. Shifting. So essentially, sign extended shifting. 0, 0, 0, 0, 1, 1, 0, 1. Okay. Shifted it 1 bit. Essentially shifted this 1 bit. This dropped out.
I heard you say sign extension. What did you mean?
Yes. So
You just carry that straight down.
So sign extension is whatever is your MS, the most significant bit, that gets repeated on the record. So in this case, our most significant bit was 0. So that essentially was reflected. Over here, our MSB was 1, so my MSB remained 1. Next step, depending on our value here, we need to determine what to do. It's 1, 0, 1, 0, subtract. I add 2's complement form, that is I add 1, 1, 0, 1, 0. So I add 1, 1, 0, 1, 0 here. On adding, let's see. What I get is check.
0, 1.
Did I go wrong somewhere? Because this tells me I went wrong somewhere.
Yeah, it should be 1 at the end. Because you're adding 1, 1, 0. That's 1.
Yeah, there should have been a 1 in the
At the
that
very
gets dropped out.
The other end. The other
at
end.
the,
The
at
other
the,
end.
at the other end, right there.
Thank you. That looks good. Okay. Again,
You should.
shift. So sign extended shifting. I repeat my 1 here and I copy the rest of it as it is. Before I go. My answer. Simple as that.
So how do you know when you stop?
Fine. So you should have dropped out all these 3 bits. I need to get rid of all this. Once I drop out all these 3, I'm at the end. So we dropped out 0 was of course dropped out here. 1 was dropped out here. 0 was dropped out here. And 1 was essentially here.
So when you're subtracting, you're taking the 2's complement of the multiplicand?
Yes, so essentially I wanted to subtract the multiplicand. Subtraction is painful. I do 2's complement addition.
And then you add, okay.